Right. Well, welcome back to 7-5, Solving Rational Equations, Part 2. Turn to page 393 and do 4, 5, 6, 7, 8 with me. You'll do these later. I'll show you again. All right, this is going to take some time because we don't have just two fractions. We have more than two fractions. Many fractions on one side, one fraction over here. It really doesn't even matter. The trick is you got to figure out what the least common denominator is and then multiply every fraction by the least common denominator. So number 4 is a little easy to see. You're going to make a list. All of your denominators are going to need an x, and they're going to need a 5. All right, this one already has the x. I don't need to write it again. So my LCD is 5x. So I'm going to multiply the entire equation, use brackets when you multiply the whole equation, by 5x over 1. Okay, remember, if I do something to the left side, I have to do it to the right side to make it equal. For this one, since I have a little extra room, I can actually write it out. It might be helpful for you to do this every time. We're multiplying this, we're distributing it in every time. So I really have 5x over 1 times, excuse me while I try to open that, 15 over x plus 5x over 1 times 4 over 5 equals 5x over 1 times 7 over x, right? I just distributed the 5x to everything. I didn't do any math yet. Because the great thing is that when I multiply these two, the x's are going to cancel out. And then 5 times 15 is 75. When I multiply these two together, the 5's are going to cancel out, and I get plus 4x. And then when I multiply these two together, the x's cancel out, equals 35. And all I have to do is solve for x. So I'll take away 75 from both sides. So that should be minus 40, and x equals negative 10. Got to look up here though. If I plug in negative 10, do I get 0? Nope. If I plug in negative 10, do I get 0? Nope. So x equals negative 10 is the answer. There is a pattern for what cancels out. If you see this pattern, then you will be able to do this faster and more efficiently. You get your LCD, you multiply everything by the LCD, you simplify before you do your basic math, right? Let's try it with something that's a little bit more complicated. Number 5. All right, this denominators, yay. Remember, there are parentheses right here, so don't try to amputate the x or the 1. What will my LCD be? Well, it looks like I'll need an x plus 1 to go to every fraction, and it looks like I'll need a 2x, and this is already a 2x, it's the same as that, so I don't need to repeat it. So my least common denominator is 2x times the quantity x plus 1. This is what I'm going to have to multiply this whole thing by. I'm going to write it over here. Now, okay, I know that's really messy. It's an x plus 1 over here. Doesn't matter because it'll be neat on the next line. When you distribute this, remember what happened in number 4? When I distribute the 2x times x plus 1 over here, the x plus 1's are going to cancel out because this will be on top, this will be on bottom. So I'm really just going to have to do 2x times 3x, which is 6x squared. Write it out if you need to. This over 1 times this fraction. This over 1 times this fraction. This over 1 times this fraction. It's okay to write it out so you can see it. Minus. When I multiply this over here, the two x's are going to cancel out. So I'm really just going to have minus 5 times x and minus 5 times 1, right? I'm distributing the negative 5 to the x plus 1. Equals, and look, right here, 2x and 2x cancel out, so I just need to distribute the 3 to the x plus 1. 3x plus 3. All right, looks like I have a squared, so I have to move everything over here. 6x squared, take away the 3x, and take away the 3. equals 0. I guess I can get out a 2. So I'll take out a 2. And I'll have 3x squared minus 4x minus 4 equals 0. I'm going to just check that real quick. 6x squared, yep. Boom. Negative 8x, negative 4. Awesome. So now I need to factor and figure out what numbers multiply to negative 12 and add up to negative 4. But I have to start out with a 3x and an x. Don't be ashamed to go on IXL and review factoring with a leading coefficient. 3x and an x. And I need to get that to be a 4, so I'm probably going to need a 2 and a 2. This will be 6. That's going to be negative. This is going to have to be positive. And I'm just guessing right here, so I probably should FOIL it in my head to make sure. 3x squared, yes. Minus 6x plus 2x is negative 4x. 2 times negative 2 is negative 4, so I'm correct. And then finally we have to solve. Top, bottom, change the sign. Change the sign. If I plug in negative 2/3 here or here, will I get 0? Nope. If I plug in 2 here or here, will I get 0? Nope. So then my answer is x equals negative 2/3 and 2. That was a lot. You might want to pause and go back. But we're going to do something similar in number 6. For number 6, to figure out my LCD, I'm going to have to factor. So that's a dots problem. And then it might help you if you just write over 1 up there. So my LCD for number 6, it's going to have an x plus 1. It's, all right, already has an x plus 1. It's going to have to also have an x minus 1. And I'm going to distribute the x plus 1, x minus 1 to everything. So big brackets, and I'm going to multiply it by x plus 1. Oh, this is going to be, I'm not going to have enough room. So keep in mind, we're multiplying by x plus 1, x minus 1, all over 1 to everything. What happens when we multiply x plus 1, x minus 1 to here? The x plus 1's cancel out. I am not doing the math in my head. I'm going to have 4x plus 1. The x plus 1's cancel out. That means the x minus 1 is left over. Equals. What happens when I multiply x plus 1 and x minus 1 to x 12 over x squared minus 1? Well, this is x squared minus 1, right? We figured it out. So the whole denominator cancels out. It's just going to equal 12. And then finally, what happens when I multiply x plus 1, x minus 1 to 3? I'm going to get 3 times x plus 1, x minus 1. But I'm just going to write that as x squared minus 1. Because I'm going to have to simplify it anyway. Pause, rewind, unpack it. You got your LCD. You realize that what is here on the top and the bottom cancels out, so you don't do any math, you just write it out. This times this, 4x plus 1 times x minus 1. The whole thing cancels out here, so you just have plus 12, or equals 12. Plus, there's nothing to cancel out here. It's 3 times x plus 1, x minus 1. I just wrote it as its dots problem. All right, now let's do some basic math. We got a FOIL over here. Minus 4x plus x minus 1 equals 12 plus 3x squared minus 3. Got some squares, which means everything's got to go over there. If I take away 3x, I get 4x squared minus 3x squared is 1x squared. If 3x doesn't have any friends, negative 1, take away 12, that's negative 13. Add 3, that's negative 10. You can check my work. You know what you're doing. Finally, what two numbers multiply to 10 and subtract to 3? That would be 5 and 2. So x plus 5, x minus 2. And that means my answers are x equals negative 5, x equals positive 2. And you got to look. If you plug in a negative 5 here, will it make it 0? No. Will it make it 0? No. 2, will that make it 0? No. Will that make it 0? Nope. So x equals negative 5 and x equals 2 are my answers. Okay? I'm going to pause here and write down numbers 7 and 8 because I ran out of whiteboards. You can take the time to finish the math on your own. Okay, I'm back with number 7. One more time, we're going to need to factor the denominator to figure out what my LCD is. Turns out, I guess this is actually the LCD, because looking at all these fractions, they're going to need an x minus 2. They're going to need an x plus 2. That one already has both of them. So I'm going to multiply this whole equation by the LCD. When I do that, the x minus 2's cancel out, so I'm left with 9 times the quantity x plus 2. When I multiply it over here, the x plus 2's cancel out, so I'm left with 6x times the quantity x minus 2. And then when I multiply it over here, the whole denominator cancels out, and that equals 9x squared. So now I got to do some combining of like terms. Let's distribute. 9x plus 18 equals 6x squared minus 12x. Oh, sorry, that's not an equal sign, that's a plus sign. Equals 9x squared. 9x plus 18, 6x squared minus 12x. All right, let's put everything on this side. So take away 6x squared. That's a 9 minus 12x, that's negative 3x. Add it to the other side. And take away 18. Factor out a 3. We're left with x squared plus x minus 6. Do you know two numbers that multiply to 6 and subtract to 1? Sure you do, but I need to use this board. So two numbers that multiply to 6 but subtract to positive 1, 3 and 2. We got to make the 3 positive and the 2 negative. And I think my answers are going to be negative 3 and positive 2. So then I go back here. If I plug in a negative 3 to the denominator, does that make that 0? Nope. Does that make that 0? Nope. Does that make that 0? Nope. So negative 3 is a good answer. Let's try 2. If I plug 2 here, does that make that 0? Yep. All right. Cross out the 2. Your only answer is x equals negative 3. Okay? All right. Moving on to number 8. Guess what we have to do to figure out the LCD? You are correct. We got a factor. Dots problem, nice and easy. So what is my LCD? Well, my LCD turns out that it is an x minus 1, because it needs an x minus 1. Oh, and it needs an x plus 1. Don't forget that's over 1. So I'm going to multiply my whole equation by my LCD. What happens when I take my LCD, x minus 1, x plus 1, and multiply it here? The x minus 1's cancel out. So I'm left with 7 times the quantity x plus 1. What happens when I do it to the negative 5? Well, there's nothing to cancel out, but instead of writing this down, I'm going to write the dots problem down as my the thing I'm multiplying. And then finally, what happens when I take my LCD and multiply it over here? Well, the whole denominator cancels out, and I'm left with 6. Let's do some math to combine like terms. Again, I keep wanting to put so many equal signs. All right, and that's a negative, so I'm going to want everything on the right side. So let's add 5x squared. Let's take away 7x. Let's add 7 and 5 together, we get 12. But then when we take away 12, we're going to get 6 minus 12, which is negative 6. And I have to factor, but I'll do that on another board because I don't have enough room. So let's just make sure this is correct so far. The x minus 1's canceled out, so the x plus 1 goes there. Nothing canceled out, so x squared minus 1 goes there. Everything canceled out, that's a 6. You distribute the 7, you get 7x plus 7. You distribute the negative 5, you get negative 5x squared plus 5. And the 6 is a 6. I added the 5x squared to the other side. I got positive. I took away the 7x over here. I got negative. I added 7 and 5 together, get 12, but then 6 minus 12 is negative 6. So I think this is correct, which means we have to do some mental math. Okay. So the only way to multiply to 5x squared is to 5x and an x. So now I just got to figure out how can I get this 6 to be, and the 5 to get to 7. So I'm going to guess that I can factor the 6 to 1 and 6 or 2 and 3. So I'm going to try 2 and 3. If I put the 2 here and the 3 here, 5x squared, that'll be 15 and that'll be 2. Do 15 and 2 subtract to 7? Nope. But what if I put the 3 here and the 2 here? 5x squared, 10 and 3. Do 10 and 3 subtract to 7? Yes, they do. If I have a negative 10 and a positive 3, I'll get negative 7. And just to check, 3 times negative 2 is negative 6. So this is my factored problem. Top, bottom, change the sign. Change the sign. So I think these are my answers. Negative 3 over 2. Sorry, negative 3 over 5 and 2. So let's go to our question. If I plug in negative 3 over 5 in the denominator, does it make any of the denominators 0? Nope. If I plug in 2 to any of the denominators, does it make it 0? Nope. So I am correct. Both of these are our answers. All right, there was a lot to unpack. In fact, it's a long video running on 17 minutes right now. Go over, try, page 396, numbers 15, 17, 19, 21. The more you practice, the better you're going to do. So don't rob yourself of the practice for this. You might be confused. You also might think it's really easy. Each person's different. Try these 4 numbers, check your answers, do them again if you're wrong, ask questions tomorrow, okay?